Good morning, Tara. You're it so far. Oh, here comes someone else. And a couple more. Oh, good. Oh, I better stop that recording. Oops. Ta-da. All right. Continuing with our discussion of linear equations in two variables. Yesterday, we explored the concept of slope. How slanted is our line? Is it going up, a positive slope, or is it going down, a negative slope? We tried to become familiar with just calculating or counting the slope or figuring it out from a graph by counting squares, the rise over run, and eventually we developed a formula that we could use if we just know a couple of points on that line, even without looking at the picture, right? Looking at the graph, we can calculate what that slope must be. So just to get us started and review a little bit, can you write that formula for yourself right now? Can you remember what we came up with yesterday? How to express the rise, right? The change in the y value versus the run, the change in the x value. Right, so you can write that little formula down for yourself. Just taking a minute for you to try to do that. Right. And then once we've got that, make sure we're all in the same formula. Let's try to calculate a slope. Right. So hopefully you're doing this okay. If we call one of our points, say 0.1 and one of them 0.2, we refer to their x values as x sub 1, y sub 1, and x sub 2, y sub 2. So the difference in the y values, that's our rise. And the difference in the x values, that's our run. Notice the y value is on top and the x is on the bottom. So here's our little formula. Try to emphasize the point. It doesn't really matter which point you call 0.1 or 0.2, right? The signs kind of make it always work out to be the same value. But now we want to plug those in. Can you get yourself started? Can you set that up? In fact, I'd kind of like to wait a minute and see if one of you would be brave enough to tell me what you come up with for that slope. I purposely put in some negative signs so that you have to work with those, maybe a minus, right? So take a minute and do that. Hopefully I don't have to wait too long and somebody can come up with that value for me.
-2, -8.
Just say that again, please.
-2, -8.
-2 over -8.
Yeah.
Excuse me. I haven't actually done it myself. We'll check it. Would you simplify that? Can you simplify that? I would say.
1 over 4
There we go.
negative.
Good. Well, I'm going to set this up and see what I get, okay? So I'm just going to say the difference in the y's. I'm going to start here. 5 minus a -7. Got my y values on top. All right. And because I started here with the
I
y,
messed up.
I messed up. Uh-oh. Maybe we'll learn something from that, huh? But you could have done it backwards or reverse order. Like I said, I haven't done this one. Just kind of made up 2 points. -1 minus 3. Now I'm going to do my simplification, all right? So I'm going to just keep going across here, remembering subtracting a negative is the same as adding, right? 5 plus, I think that's maybe where you went wrong, huh? 5 plus the 7, we're going to get a 12. -1 minus 3 more, minus and more minus, right? There's your minus, there's a -4 is what I got. Well, positive divided by negative, I'm going to get a negative number. I'd simplify that to 3 over 1. I've been doing that right now just so we see both the numerator and denominator values. We might just call it a -3. Let's see, I'm wondering. Well, I'm not quite sure where you got your numbers from. See if hopefully you can figure that out and rearrange that, okay? If it makes sense. Hey, let's just do one more, okay? Somebody had an issue here. Let's just do that again. Any questions with what I did there? All right, so let's erase this. All right, and just again, make up 2 points. Here we go. And try it again. Let's see what we can come up with for the slope. You get a value, chime in, okay? Thank you, whoever did that, gave us that answer last time. I know it's not always easy to be the volunteer. Anybody want to give us a value?
I'm getting -6/5.
Okay. How'd that work for anybody else? Not sure? Well, let's
Same
see.
thing.
That's a good sign. All right, here we go. -5. Here I'm doing my difference in my y's, right? -5 minus a -1. I think we're having some minus problems, perhaps. Now I started with this y value, so I have to be careful to start with that x value. 2 minus 7. What do I get in that numerator? Subtracting a negative. That stuff we did in the first chapter, it comes back over and over, doesn't it? -5 plus a 1, fully -4.
You put 2 minus 5 there.
And I did. I was looking at this 5, looking at that 7. There I did it again. My brain's thinking ahead. Thank you for catching me. 2 minus the 7, right? -5. Now, we're going to get, so again, I'm not sure what happened there. I'm thinking maybe you mixed the signs up. Maybe you did it in reverse order. You chose the points in the opposite order, but I've got negative divided by negative. I'm going to get +4/5. All right. Better double check. -5 minus a -1. All right. And 2 minus 7. Does that work for you now? I think
Yes.
I think we're going to do one more. I'm going to put some negative signs in again. All right. Oh, I'm stuck on 7s this morning, I guess. Now let's see, -5 and a 2. 3, -7, -5, 2. Probably did the same values over and over, but just mixing them up a little here. All right. Now, let's set this up. I'm going to say -7 minus 2. You could have done 2 minus a -7 if you wanted to think of it backwards. I start with this point, y values here. I have to start with that x. 3, and that's a -5. I kind of squeezed it in, all right? Minus a -5. Any questions or issues with that so far? All right, well, -7 minus 2 more minus, -9. What do I get here? 3, subtract a negative. It's the same as adding, all right? 3 plus 5, 8. So, to get there that time, I hope. -9/8. Well, we'll have to keep practicing that, right? And that's why I was putting in the negative signs. I guess that's still messing up some folks. We got to keep practicing that. But we're going to continue with our concept of slope and look at how that fits into the equation of a line and how we can use that information perhaps to graph that line. All right. Let's take an equation in 2 variables for one of our lines. All right, y equals 1/2 x plus 3. There's one of our familiar equation shapes. All right, and early in this chapter, we figured out how to graph this just by picking some values to plug into the equation for one of the variables and finding the corresponding other variable. When it's in this shape, I've usually recommended it's easiest if you kind of pick some nice values for x that'll work with what's here, do all the work over there, and then we get our y value output. I've got a fraction, so I've also suggested let's pick some nice numbers. You can pick anything you want that work well with this 2 as a denominator. So how about any multiple of 2? Well, I usually do something like this. All right, there's multiples of 2, and if I plug them in for x, I can find the y value. So if x is a -2, right? And here I kind of write that as a fraction. So I see, because I'm going to multiply as a fraction with a fraction and go from there. All right, so here I get -1 plus 3. I'll get that y equals a 2. There's 1 point. Call that an ordered pair right there. Huh? What if my y is a 0? Excuse me, my x is a 0. So I say, well, that just cancels out. I'm going to get y equals 3. And if I put in a 2, that's going to be a 1 plus 3. I'm going to get a 4. I've got 3 points I can put on a graph, connect the dots. Any questions about the calculations I did there? I'm going to get that out of the way then and use this graph grid over here. I'm going to put those points on my graph. Let's see, -2 and +2. All right. 0 got me up to 3. 1, 2, 3. And I was at x value of 2. I was up to 4. Do that pretty well. Connect the dots. And all right, you know what we're talking about here. All right, there's the graph of that equation. We talked about the intercepts, the y-intercept in particular. Can you look at that graph? What's the y-intercept value for this equation? Well, y-intercept, where is that? That's where I say it's the other value, that's the 0. Y-intercept of x is a 0. Oh, that's this one right here. There's my y-intercept value, right? 0, 3. What's the slope of this line? Well, what we did yesterday, we looked at our graph and we counted the squares. The rise over the run, the slope. Let's see, I could start from any point and move to another point, but my rise, right? If I went up 1, right? If I went up 1, I go over 2. Here's my slope value, 1/2. All right, look at the graph, figure that out. Now, look at those values I just calculated or asked you to try to follow along with me and compare it with that equation. You see those numbers? That's what we're getting at. My slope value of 1/2. Well, look at that number that's multiplying my x. There it is. All right. And my y-intercept value of 3, the y value of 3. Look at that number that's added there. There it is in my equation. This is what we're trying to recognize today and use when we have an equation to work with. The equation in this shape shows us our slope value. It's the factor that's modifying or multiplying the x value. And anything that's added or subtracted, or maybe it's just a 0, that's our y-intercept value. So we have very nice, important information right there in that shape of the equation that we can use. We can use it to graph without doing the table. All right. Now, that equation shape, we've talked about it, or I've presented it in this sort of abstract form and said, oh yeah, we'll talk about those letters later. But look, there's the m that we've been talking about all along for slope, right? The slope is the number that multiplies our x value. B, well, somebody decided it should be a b, but the b is the y-intercept. Whoa. In that equation shape, the m is the slope value, and the b, or added or subtracted value at the end, is the y-intercept value. Because of that nice information, we call this form slope-intercept form. Right? This version, right? We've looked at that other time that had the ax plus by all on one side. This version tells us the slope, tells us the intercept, so we call it the slope-intercept form of a linear equation. If we have an equation in that shape, we can recognize and pull out the slope value, we can recognize and pull out the y-intercept value, and we can use that to graph the equation. I'm going to scoot this up a little bit. So if I just put some equations up here, and we do that. y equals 2/5 x minus 1. What is the slope of this equation? What is the slope of the line that this equation represents? Okay. Well, there, m is the number on x, multiplying x. There it is. Our slope for this line is the slope of 2/5, up 2 over 5, up 2 over 5, forever. What's our y-intercept value? That b, or extra added number out here. Remember, we can think of this as adding a -1. So our y-intercept is that -1, that negative value. If it's a negative number there, it's a negative y-intercept. All right? So just being able to look at the equation and pull out those important values is where we're continuing right now. Here's another one. Y equals -4/3 x plus 5. What's the slope of that line? I know, you wait for me and I tell you. But hopefully this concept is sinking in. That number on x, the slope, -4/3. Or I could say, oh, let's go, let's go down 4 and over 3, right? A -1, negative slope. And the x is always 0 here, right, for y-intercept. Careful, mom might ask you to express the y-intercept as an ordered pair. So you still gotta, you can't just say 5, right? You gotta show the point, x and y, ordered pair. Oh, drop the clock. Now, sometimes equations aren't in that shape. All right, so how about and just looking at it right now, we don't know what the slope is or the y-intercept because it's not in that slope-intercept form. So we can do some work and rearrange it. We can solve it for y. Remember, we did that last chapter. Right? Here's y, it's got this extra plus x. It's being multiplied by 4. We want to undo that stuff around the y to get it to be in this slope-intercept form. Here I would probably subtract the x from both sides. If I do that, the y's are still there. And I'm going to put it in this shape with the x first. If I'm subtracting the x from both sides, it's a negative x here, and there's still the 8 over there. I could say I did minus x and minus x. All right. I want to get one y, so I'm going to divide everything by 4. It's kind of like multiplying by 1/4. I divide everything by 4. I'm going to call this -1/4. So that I kind of see the fraction out in front and not just x over 4. Now it's in that shape. Right? Now it's in that slope-intercept form. And hopefully you can say, oh, the slope is -1/4. And my y-intercept, 0, 2. One more like that, okay? Just practicing these things that we did the last couple chapters, like adding or subtracting with negatives. We're solving for a variable here. You'll have to do this once in a while to get it into the preferred shape. Let's solve this one for y again. You doing it? Haha. I'm going to subtract the x's, leave the y over there. Subtract the 3 x's from both sides, all right? I could say 12 minus 3x or -3x plus 12 over there still. Just because we're working with this shape, I'll put the x's in front. Otherwise, we'd say that 3x is being subtracted from the 12. But if I think of it as a negative value, I can just put that in front like that. Divide everything by 2. This gets divided by 2, and that divided by 2. 6. Now it's in our slope-intercept form again, and I can say, oh yeah, my slope is -3/2 and 0.6, my y-intercept. Okay, that's nice. What do I do with that? Well, if I know a starting point, and we did this yesterday, if I know a y-intercept or really any starting point on the graph, and I know the slope, I can graph it perhaps more easily than building that t-chart and plotting points, calculating a bunch of points. So how about, oh, like my good examples here, right? Let's graph this equation using the slope and the y-intercept. All right, use the slope and the y-intercept. And you'll see these instructions in your homework problems, perhaps, and probably eventually a test question. Graph that using the slope and the y-intercept. Well, what's the slope of this equation? 2/3. What is my y-intercept value? That number on the end, -1. This is kind of where we ended up yesterday. If I have a point and I know the slope, I can put that point on the graph as a starting point. -1, 0, -1, there's my y-intercept. Now I can use the rise over run, basically count squares and come up with a second point, and then I can connect the dots. So I'm going to go up 2 and over 3 from my starting point. You always got to have a starting point, not just the origin, right? Up 2, 1, 2, and over 3, 1, 2, 3. That's my number 1 there, right? So I've got 2 points. Connect your couple of points. Use the little mom pencil, whatever. I always like the arrows on, fills it forever. And there's the graph of that line. There's the graph of the line that represents that equation. Let's do it again. Any question? Slow down, slow me down. Okay. Another one, y equals 4x plus 3. What is the slope? We're going to do the same thing, use the slope and the y-intercept to graph this. What's the slope value? It's that number on the x, multiplying the x, a 4. What have I been saying about integer slopes values? Let's write it like a fraction so that we see the rise and the run values. 4 over 1. Okay. And my y-intercept value, 0.3. So this is, math teachers get excited, right? This is important information we can pull right out of this equation. Look at that, now I know I can start here at 3. 0.3 for my y-intercept, and I can do, if I go over 1, I'll go up 4, or go up 4 and over 1. Over 1, all right, over 1, up 4, 1, 2, 3, 4. And that has to be another point on the line of this equation. And here we go, connect the dots. Positive slope, we expect it to go uphill. Notice we've done several with fraction slope values, less than 1, right? I kind of refer to that, you might expect that slope becomes shallow, but here's an integer value, a 4, it's pretty steep. There's kind of things to help yourself recognize or anticipate what it should look like. Does it make sense? Huh? And then, of course, they make it trickier or something, right? There's all kinds of variations we could have. Let's do a negative slope value one here. Right? What's the slope of this line? We're still doing the same thing. Graph it using the slope and the y-intercept. The slope is a negative 5/2. The y-intercept, a 1. All right, so that's no big deal. I can put the 1 on the graph. How am I going to use this slope? Here's where I've made the point. I've got generally a negative overall fraction value. I need to reinterpret that as like 1 positive, 1 negative, a division of a positive divided by a negative or vice versa. So it doesn't really matter which one. Make one negative and the other positive. And I could have made the other, I could have reversed it if I want. I could have made it 5 and -2. But yeah, I got to choose. So I could now think of one direction as positive and the other direction as negative. So there's my starting point. And let's go down 5. My rise is really a negative rise. Down 5 and over 2. 1, 2, 3, 4, 5, and over 2. There is the second point for that graph. And negative slope. We should expect that it's going to look like it's going downhill unless you do something, you did something wrong. Okay. All right, I'm going to put one up here. Let's see if you can get yourself started. You do it. Okay. And kind of like that one. Okay. On your own paper right now, right? You write down what's your slope value, what's your y-intercept value. I'll check in here with you in a second. From that equation, you're getting it, you're pulling out those values. So hopefully you've got -3/4 for your slope. And the b, that extra number there, a 2. All right. How would you like to interpret that slope? As a division, positive divided by negative or vice versa, huh? Let's do it this way. Oh, I'm going to do it this way. I ask you to get started. I'm going to put the negative on the bottom this time, just to do it differently. Okay. Positive divided by negative. Here's my starting point. All right, and this says if I go up 3, I'm going to go back 4. All right, up 3, rise, 1, 2, 3, and back 4. Uh-oh, squeeze, 1, 2, 3, 4. I was afraid it's going to run into my equation here. And so I have a second point to use. If I had done it the other way around, right? -3 over +4. Here's, I sort of pointed this out yesterday. This would be going down 3 and +4. Down 3 and +4. I find a different second point, but we weren't looking for a specific one. We were just looking for a second point that was on that line. And key little bit, make my line go through, whoops, all 3 of them. All right. So I made the point, sometimes you might be over here looking for a second point, you'd rather go backwards. Something like that, up here. All right. Yeah. Just kind of doing a bunch of this is the main thing today so far. How am I doing time-wise? We're doing all right. Here we go. How about one of these? Now, what is it, section 4.3? We looked at equations like this and said, well, if I really just had to graph it, maybe using the intercepts would be an easy way to do that. But we're practicing this technique today. So we're going to rearrange it and put it in slope-intercept form. Okay. First thing we usually do, right? We're going to leave the y. We do it differently. I'm going to leave this y. Right? And it means I'm going to subtract the x's. So I still have a negative sign. That's kind of what made me say, oh, I could do it differently. I guess I could have added the y. But I'll do it this way to start. How's that? So far, first step, move the x's. But I have negative y. So I'm going to multiply everything on both sides times negative 1, right? Everything times negative 1. I get positive, positive, but negative 6. Okay? So there I rearranged it, solved that original equation for y. Now I've got that, and I'm going to get this out of the way. I can say, oh, yep, my slope is a 2. I'll think of it as 2 over 1, and negative 6. A y value of negative 6. 0, negative 6 is my y-intercept. Got to put a starting point on there first. 1, 2, 3, 4, 5, 6. Negative 6, assuming 1 here, and up 2 over 1. Up 2 over 1. Second point. Connect the dots. All right, let me cheat. I'll get away. I guess I can just do this. Save my ruler. Okay. What if I've got something that looks like this? Especially if we get into application problems. We start running in, whoops, don't forget my X, Steve. Application problems, we might find decimal values rather than just fractions. Like that might be 50 cents or something like that, right? And big numbers, depending on the context of a problem. You could have all kinds of different numbers over here, right? But we still can use the same technique to graph it. And eventually, use our graph to maybe predict other values, something like that. What's my slope here? Well, it's this 5/10, 0.5. And my y-intercept is 25. What do I need to think about here? Well, I'm going to graph this. First of all, how do I want to think about this decimal value? I've been working a lot with the fractions. Maybe it's just easiest if I think of that as a fraction. 5/10. Okay. 25. I'm running out of room. I need to change my scale. That's what this, one of the things about this example. Of course, the decimal value is one thing, but I'm going to put some big numbers on this graph. How big do I want to make my y values on my axis? 1 times 25, or 1 plus 25, or this could be 50 plus 25. How about we say, I'm just going to call these 25s and see what happens. All right. Every y value line is going up by 25s. 1, 2, 3, 4, just to give us a reference. 1, 2, 3, 4, 200. Hopefully that's going to work for me right now. So now this slope value, 5/10. But even if I use that, I could reduce to 1/2. Right? And I'm guessing, okay? The context of this problem, I'm not likely to, maybe I'm not going to get 1 plus 25 or 2 plus 25. These might be some bigger numbers. I'm gonna call these 10s. See what kind of mess I just made for myself, okay? I'm gonna call my x values 10s, right? 10, 20, 30, 40, 50. All right. And now I'm going to try to use my slope and my y-intercept to graph this. Let's see, did it work? Okay, 0.25. All right. Now this says if I go over 5, excuse me, if I go over 10, I go up 5. All right, if I go over 10, I go up 5. Well, every one of those, yeah, I'll go over 10, I go up 5. So that's a problem when you get into really big numbers or different numbers. You got to pick good scale values. All right. What if I'd gone over, say, what if I did something like this and say 25 over 50? Well, that says if I go over 50, I get to jump up another 25. So if I go over 50, I can jump up another 25. So I'm finding nice versions here in a sense of that slope value to help me graph that nicely. Yeah. This is really an application problem I was working with. I might play around with the scale a little more. Suppose I could have compressed it more or maybe stretch my x-axis values a little bit. But interpreting the decimal as a fraction, often a good idea. If you're adding or subtracting large values, well, you've got to choose some values for your y-axis units that are appropriate. All right. I'm going to change gears here for a second. And, yep, I have time. All right, you want to be able to interpret this information. I'm going to share my computer here for a second here. All right. Let's see, share, and I'm going to go over here. And if this is working for you, you should be looking at a page out of our text. All right, let me know if that's not what you're seeing, please, okay? This is a page out of this text section and a couple of the homework problems in this section here. We're in 4.5. So let's just look at that first one, 342. All right, and think about what they're asking us to do in this equation here. Costa is planning a lunch banquet. The equation, C equals 540 plus 28G. Oh, this one already. Models the relationship, right? X's and Y's, the relationship between the cost in dollars, which is what the C represents, and the banquet and the number of guests. So G is the number of guests, and eventually you can use that to figure out the total cost of your banquet. So find the cost if the number of guests is 40. What are you going to do with that number 40? Read it carefully. What is it saying? The number of guests is 40. How do we use that 40? Which value in our equation represents the number of guests? Well, let's see. The number of guests is G. So this part A is telling us replace the G with the number 40. So in that equation that they gave us to work with, we're going to put a 40 in for the G. And if you do the calculation, you'll figure out how much it would cost to hold that banquet for that many guests. And similarly, the next question, find the cost if the number of guests is 80. It's the same kind of question, right? If I put in 80 for G, I can figure out the total cost. This next one's kind of what I'm getting at. Interpret the slope. All right. What's the slope number in this equation? Now, if you look at it, it's not quite in mx plus b, y equals mx plus b shape, but it's a not unusual variation. Think of it as y equals b plus mx. They just reversed the order. So the g is like the x. What number is on the g? That 28. There's your slope value, is 28. what does it stand for in the context of this question? We're calculating cost based on the number of guests, right? Cost per guest. Oops, that's kind of like the units for that, right? Cost per guest. The 28 tells us the cost increases $28 per guest. That's what you want to kind of be able to get out of this equation and the information there. What does the y-intercept mean? All right. In this case, the y-intercept came first, the 450. All right. What does that mean? If you hired this person to do your banquet or whatever, even if nobody shows up, it's going to cost $450, right? If G is 0, your starting point for this service is 450. So that's a process or way of thinking that we want to be able to do with our application problems. I'm going to scroll up. I thought I was on one that was in. Notice that many of these, I'm just scrolling up, are in that reverse MX plus B or B plus MX order. This is that idea I've mentioned before. There's often a fixed cost or amount. Like in 340, there's a $400 fixed amount and then a 0.15 times C based on. So this is her total commission, right? So that's not an unusual variation of our slope intercept shape. 338, Bruce drives his car for his job, okay? And this one describes the relation between the amount in dollars, R, that he is reimbursed, and the number of miles, M, he drives every day. So you could parts A and part B, plug in those values and figure out his reimbursement amount. But part C, interpret the slope. The slope value here is that decimal, 0.575. What does it mean? This equation is describing the relationship in dollars between his reimbursement amount and the number of miles he drives. Does it make sense? He's getting $0.575 per mile. Really, the units on the R and the units on the M are kind of tell you the units of that rate, that slope, right? Dollars per mile. And if he doesn't drive, he showed up at work and they didn't make him drive, does he get reimbursed anything? Even if he drives 0? That's his y-intercept, that M. Excuse me, that y-intercept, that 42. Thinking different things at the same time. All right, I wanted to take a look at those couple word problems, applications, and think about interpreting the slope value and the y-intercept value. I'm going to go back here for a second. Back. Okay. So what we've done so far is pretty much gotten about 2/3 through section 4.5. And tomorrow we come back and we do a little more and of 4.5 and look at some more relationships, like what's special about parallel lines or perpendicular lines, and can we tell that from our equations? But you can get started on 4.5 if you'd like. I'd encourage you always, not to wait till last minute. Go give them a try while they're fresh, perhaps, while the ideas are fresh. And I was looking over your mom problems. Many of them actually have several parts. So there's 15 questions there, but there's like parts A, B, and C. So, that might seem like a little longer than some of them. So I encourage you to get a head start on them, all right? If you guys are okay with that at this point, then I think we're gonna wrap it up for today. And then tomorrow we will pick it up where we left off here, review a little and continue, and finish up with our slope intercept form section. Okay? All right, folks, well, have a good day and I'll see you tomorrow, all right? Okay.
Thank you.